Good afternoon, everyone, and welcome to a presentation from my home about bringing the .NET SDK to the cloud. My name is Ewout Kramer. I work for Firely as Firely CTO, but I think in the context of this presentation, it's more important that I have been involved with the development of the Fire SDK, Firely's Fire SDK, for the last 10 years. What I'm going to tell you about today is how we are going to bring the .NET SDK to the cloud. That's not as easy as it could be, or as it sounds, if it sounds easy at all, because the SDK has been around for about 10 years. And just like the Fire Happy SDK, SDKs are something you want to keep stable. So although we'd love, in the past 10 years, lots of things have changed. When I designed the SDK, you basically had Fire clients and you had Fire servers. And the idea of using some of this functionality, scaled out widely in clouds and Lambdas and whatever, that didn't exist. So what we want to do here is have some baby steps to make sure that we enable our SDKs to be used in these new kinds of environments without breaking all the existing code and installations. And as anyone who has designed an SDK knows, that's the fun part of maintaining an SDK, but it's also pretty difficult. So we'll take this step by step. Before I start, though, let me give you a brief overview of the interesting parts of the .NET SDK and our other products that could be, migrated into a cloud environment. So on the one side, there is the .NET SDK. Started out 10 years ago as a library to parse XML and JSON. And I kept on adding functionalities like Fire Path Evaluation. There's Fire Client functionality there, but that's not so relevant to our discussion today. Then profile-based file validation, so validation that takes into account structure definition and terminology. So obviously also the .NET SDK has a lightweight terminology service. All that functionality and stuff is used in our products, Simplifier, but also Firely Server. And Firely Server adds on top of that. So Firely Server exposes functionality that's packaged in the .NET SDK, like the validator using $validate, the lightweight terminology service using $validate code, but it adds things like implementing the Fire REST interface, implementing the search capabilities. So it has an index engine that might be of interest to isolate from Firely Server and offer that to customers. And it has bulk handling and subscriptions and mapping and parts generally that you might think about exposing outside of Firely Server as separate components in the cloud. Now, over the past 10 years, no, that's not true. The last year or 2 years or so, it became obvious to us that we needed to make that move because we had the growing wish list in our customers too around doing these kind of cloud functionality. So what's the kind of things that we specifically want to achieve with any new versions of the SDK? Well, a very common question is, this functionality exists in the .NET SDK, but can I use that standalone? The validator is a good example. It is there in an assembly, it is there in a NuGet, it's packaged in Firely Server, but if you want to use it standalone, you either have to use a full Firely Server installation or write a kind of wrapper around the validator yourself. Well, writing that wrapper, writing a smart wrapper that can be scalable, that's the kind of things that we like to do for our users. Being able to deploy this functionality in separate, smaller blocks also allows you to scale more granularly. Containerizing the Firely server and scaling that up is a possibility if you need more compute power. But it would be much better in most cloud situations if you take just the terminology servers or some very the compute intensive validator and be able to scale that separately. So and finally, of course, our .NET stack is not living all by itself. Most of the time, you have existing, well-tested functionality and you want to integrate that with our .NET stack. Now, Filey Server allows you to extend Filey Server, but that's obviously currently with the plugin system that only accepts .NET components. And it's also pretty hard to say call any parts of a .NET validator from Java or vice versa, or TypeScript, whatever. So packaging this up in lambdas or functions is an obvious thing to do to be able to create a complete solution where parts of the solution come from different tech stacks. So fun. There's enough literature, there's enough knowledge. Some of the old books became relevant again, like our enterprise integration patterns, the great classic, and we started to sniff around. Really also looking at the pretty pictures of what some of our fellow competitors did there, and we drew our own, admittedly not that as pretty picture, but something that sketched where we wanted to go. Where do we want the .NET SDK to function? What's going to be the environment? And so here's an AWS cloud environment, but it could be any, could obviously also be Azure. And center part here are the prime candidates currently buried in the .NET SDK that we could deploy as separate functions. Create a wrapper around it. I'll zoom into that later, and offer them as separate components. That means that there's still stuff left in Filey Server, of course, and so Filey Server will continue to exist as a containerized application, but it might more and more depend or use components that are external to it written in a different platform, operating in a cloud-based ecosystem. One of the things we might take out of Filey Server, for example, is it's an indexing engine, since that implements a full file search. So it would be really easy for you to develop third-party solutions that require file search without needing to install a full Filey Server. And well, the whole aim of the game is to integrate with third-party services. So maybe a Java-based containerized MLP receiver can put its stuff using the cloud provider's infrastructure, like queuing systems, and connect that to these new Lambda functions. I think you're smart enough to translate some of these AWS lingo to Azure. I'll leave that to you. Good. So I already said the aim of the game basically is to take the package functionality currently in the SDK and repackage it. And let's look at the prime candidate, which is validator. How would we repackage that, and how did we do that? Well, the validator needs inputs. At minimum, it needs data to validate, and also, of course, it needs a profile to validate against. So these are basic inputs. Let's take a look at the data. One thing we could do is take the data from a database. So connect it to Filey Server database. But that would not scale well. It wouldn't allow you to invoke the validator if you're not using Filey Server, obviously. It would not enable you to validate data that is not yet stored. So you want to validate it before you store it, for example. And also, it wouldn't give the validator full access to patient data, and that is not necessary. So the obvious thing to do is just send it to the validator using Fire JSON. So one thing our wrapper has to be able to do is receive a JSON payload and over HTTP. Another alternative certainly is to look at Protobuf and Grpc. And if you were with us at the pub talks on Monday, we did discuss this in some depth, and that's clearly an option we're keeping open, because within a data center, within a cloud setting, it would be really good if your components, if your lambdas didn't have to deserialize and serialize back and forth to JSON all the time for each invocation. Also good for performance would be the fact that you don't send that data completely from component to component at all. You store it once in blob storage somewhere, and then maybe a pipeline just points to the address in blob storage. And this is what our validator does as well. It can retrieve the data from blob storage and validate it from there. So Packaged within that validator is obviously the JSON parser and the firepath engine. We decided that packaging the engine as inside the validator was a better idea than having the firepath engine as a separate lambda or a separate function, since validating an instance invokes hundreds and hundreds of firepath statements. And so although it would be conceivable that you'd like a firepath functionality as a separate function, and we could do it, at least the validator has an in-process packaged firepath engine, just like it has a lightweight terminology service, which will serve the most common terminology queries, like, is this simple code in this simple flat value set? That's 99% maybe of all validation queries. And certainly we can call out a slightly more expensive call to a terminology component running as a Lambda, or maybe even a web service that serves the more complex queries. Finally, of course, the profile validator itself is packaged there. Output of the validation process is an operation outcome as a JSON, and that can be forwarded in your pipeline to the next block. And finally, logging and telemetry data. We have rewritten parts, so we have better logging and telemetry for these blocks. What I've skipped over so far is actually one of the most important points, and that we had to solve. And this is what I'll focus on in the coming slides, is how to deal with the conformance data. So structure definitions, value sets, and so on, because the validator can't do without it. Actually, you can't even parse without structure definitions. So for anything you'll do, you need conformance data. And as you probably know, conformance data is packaged away. The fire spec itself or US core is packaged in NPM packages. So if we deploy these with the validator, it means that on every cold startup of a Lambda, it would have to be unpacked, parsed, indexed, and so on. So we don't do that. Our solution is something we call Conformance Archives. And Conformance Archives are pre-compiled NPM packages. So on the one hand, you have these NPM packages that are supplied by the spec. These are our inputs, one-on-one, we don't change them at all, containing all these huge XML and JSON files, and we take them apart. So we wrote a sort of compiler, we call it the CAR file compiler, the Conformance Archive compiler, and we calculate the closure of these NPM packages. So the idea is that a CAR file contains everything you need that is referenced by the main IG that you're implementing, or the IGs. So everything is in that single conformance archive. I'm lying a bit there, because any Fire instance can reference an external extension that you didn't know of before. But I think in many cases, people really don't want to validate those external extensions because they don't know about them, even though the validator could. But they won't be packaged in this conformance archive. Well, there is a third, fourth level cache where we can put those. So it's not impossible to do, but they won't take the speedy path, right? So if those are encountered, we'll go out, fetch structure definition and validate it if you really needed to. But we think that in most cases, you'd like this stabilized version conformance archive where everything is there and compiled. So we calculate the closure, we turn structure definitions in something that we can easily and quickly use for our validator, which we internally call an element schema. We turn value sets into simple lookup tables and denormalize search parameters, pre-process them so they can easily be used in our search algorithms. We pre-calculate snapshots, all that stuff, we validate it. So basically, by the time it ends up in a CAR file, it's indexed, normalized, checked, parsed, and so on, and so on, and so on. And then we store everything in SQLite. One SQLite file. So an IG in a file, basically, or IGs in a file, in a single file, in a binary format. Well, once we solve that puzzle, now the rest becomes pretty easy. So our build delivery pipeline takes an NPM file for, say, a certain IG and compiles it to SQLite. We compile the latest version of our validator and all its dependencies, which are .NET DLLs, and deliver them to our cloud environment. So we have a registry of car files there for most common combinations, or maybe a specific one made for you. And we have a library of functions, and we combine them when we deploy them in a certain installation. So depending on the customer, we deploy them. And so for a US customer, we can have US-based IGs in the car file plus the necessary library of functions. That solves the problem for cold startup. It solves the problem of hitting invalid metadata at runtime because most of that is caught by the car file compiler. That's all done and ready. We got that running. And next up is that we're working towards composability. Our components don't run in isolation, basically. We need them to communicate in between them, and we need them to receive data from the infrastructure of the cloud provider. So currently we're looking at how we can standardize that a little bit so they can be plug and play used. So you can use our components with the infrastructure ones and amongst other Filey components. So those are things about how does a pipeline work, how do we forward errors, and so on and so on. We don't do that all by ourselves. We do that with Black Bear Software. They have experience in deploying these kind of things have their products deployed basically in AWS. So they had lots of ideas about this composability of pipelines. So we're working with them together to create some kind of FHIR cloud communication messaging format that we can use for composable Lambdas. But that's something for another talk. That's all that I wanted to tell you about for today. This is where we stand. We have all this ready in beta, and you'll probably hear a lot more about it in the coming month. I am around for questions, and I'll monitor the Q&A as well. So if there's anything you'd like to ask me, just go ahead, and I'll talk to you later. Bye-bye.
Hey everyone, this is Bryn Evans from HL7. I've got Mr. Kramer here to answer your questions. Ewout?
Yep, I'm here. This is live. So don't hesitate if you have any questions. Again, as I said, I'm part of the team here, so I'll stick around if you have more in the Q&A. But
hello, Ewout.
From Brian. Yeah.
Hey, Gino.
Sorry, I had a call come in. That's why. I saw that someone asked me to unmute, so I have unmuted.
I can hear, and I heard Marco too.
I threw a question into the chat. Have you considered how to inject other validations like questionnaire validation?
Yeah, but I'd really see that. That's the whole point, actually. That is pretty hard now, especially if that we didn't write that in .NET yet, but say someone else wrote it in .NET or another platform. Because we're now going for integrations based on Azure Functions or AWS Lambdas, you could package that questionnaire validator in a Lambda, and you could compose a workflow where, say for example, you first invoke the validator for the basic questionnaire validation against a profile, and then forward it to the next step, and that's your packaged component, the questionnaire validator. And and I think that was the last slide in the presentation.
Yeah.
To make that composable, so for the second component to understand the output of our first component, that's where this composability messaging format comes in. So it would be really useful if you'd wrap your component to stick to that format. But obviously you could inject into that pipeline other components that would rewrite it. But yeah, that would be the way to do it. So rather than add it to to the Filey server stack or add it to the validator and make this big monolithic thing, let's keep that small. Yeah.
So I guess that's kind of means that from a pipeline perspective, you'd need the source resource plus the outcome resource.
Yeah, the outcome resource. That's for many of the outputs, at least for the validator, it's the outcome. Would it also be for? Did you write one, Brian? A questionnaire validator?
Yeah, I do.
Yeah. And so you output an operation outcome.
Yep.
Yeah.
Yeah, and I'll note that's one of the great things that Firely did with all this being open source is you can kind of experiment. Right now I'm looking, that's on my list very shortly to get to, is playing with like fluent validation in C# and kind of using that style of API to build out validation that doesn't need terminology resolution. So you can do everything except, obviously, if you have a SNOMED or SNOMED code or something, you're not going to validate that, try to build that all in compile time or anything like that. But those types of things that you can get a lot of the way there. And if you can get 85, 90% of the way there with some relatively straightforward code, then those are the kinds of things. And we can build and play with them. So. Cool.
Yeah, it's a lot of the validation stuff is pretty easy, except for the things like slicing and so on. That's always the headache.
Yep.
But yeah, we redid our validator as well for the for this, to make this, well, not necessarily to make this possible. We took this more or less as a chance to re-engineer our validator, so it becomes easily extendable with custom validations. So Gino, I'm really curious about whether we are either doing more or less the same thing, or maybe things that could be integrated.
Yeah, hopefully as we sync up again, it's obviously one of the challenges that it's like, oh, let me try out this idea because it's some off-the-wall idea and let's see what happens. So it's not quite ready to actually work yet. So
no, but maybe you can whisper in my ear. Yeah. Nice. Thanks. Yeah. I mean, the fact that we had to relook at our code to make this work in a cloud environment also enabled us to revisit some parts of the, as I said, sometimes 10-year-old code base. And that's, of course, well, every developer knows that there's always a bit of code hanging around that you'd like to fix until there is a business need. Now we have one. Though, since this is an SDK, there's, of course, no way to, or I'd rather not change the public interface, let me say it like that. That's always what's holding you back to do to make big changes there.
So, I mean, along those same lines, does it work with arbitrary resources as long as they're conformance resources?
That's right. Yeah. Most of the .NET, well, yeah, most of the components we write are not using directly the generated classes for each resource, but they are just dependent on the structure definitions. So they could validate CDA if you wanted, and really you could add structure definitions for custom resources, and it will validate it in exactly the same way.
Well, no, I mean, does like the conformance archive, like if I have an IG where I include like concept maps or libraries, since they're conformance resources, would those also be included in the conformance archive?
Ah, well, that's certainly what we would do. I mean, I will admit that we focused on structure definition and value set now, but it's a very obvious place to do the same thing with the concept maps, because though what is important is that for each of these resources, we thought about what is the most efficient form for us in the API. So for our terminology servers, the most efficient form for value sets was to create just a table in SQLite, with the key, which lists the codes, which is very fast. And for the structure definitions, we're throwing away a lot of stuff from the structure definitions and compiling them to a binary form. So we'd have to think about why would we use the concept maps. But there is a general, so in the .NET library, we parse all the instances into something called itype element, which is our, say, a generic tree form for all fire data, and we can serialize those to the car file. So we could include examples, concept maps, anything we need in into such a file. And basically, the setup of the car file is that if then afterward we think of a very efficient format for some kind of output format that's more efficient for a certain target use, we could add that as well.
Okay.
Yeah,
that makes sense. Cool.
I think we also have to be careful that the car files are not getting too large, probably, right?
Yeah.
Then you need to change it to a bus.
Yeah, yeah,
Bus files.
that is right. And before you know it, you'll have car files lazily loading other car files when necessarily. We all know where this is heading if this becomes large. But since most of the most of the binary formats that we use are pretty efficient, so we have some handwritten serializations into. What was it called again, Marco? That serialization format?
Failed me there as well.
It's a standard, very efficient binary format. It's not gRPC because we don't have the. It's something with. Oh my goodness!
I'm opening the code now.
And normally, just 5 seconds before you find it in the code, you realize the name.
Message back.
Message back. That's right. Yeah. There are message back deserializers and serializers for all platforms. So we figured that would be that's a nice technology to use, and it's very efficient. So we can store quite a lot of conformance data in the car file before they're becoming huge. We have a little bit of optimizations there. For example, all the canonical URLs, we don't store them, we don't repeat the strings for each of the canonical URLs. We just make an index with because otherwise, your car file fill up pretty quickly with all those strings.
Just thought I'd pop in to say that we are technically over time. This meeting doesn't end, though. Nobody else is coming in here. If you all want to hang out and talk, for as long as you all want to hang out and talk, I'm not about to kick you out. So,
Thank you.
Standing. As a note, I don't know if people want to turn on the cameras or not, but it is not permitted right now in the meeting.
Oh, is that maybe something a moderator?
That would be my fault. That would be my fault. All y'all, turn on yourselves.
No worries. I know it feels weird to be the one person with your camera on and everyone else is just their name square looking back at you. So.
Well, thanks, Gino. I know you generally turn on your camera. So now we're with a smaller company. We can go to the in-depth questions. Throw them at me. What do you want to know? I'm really curious, Gino, about what you made up with your fluent validation stuff there, but I don't know. Huh? Is that my problem or yours?
For the record, I can hear you. I don't know what exactly is going on with Gino and.
Oh, so you can hear me? Okay.
Yeah, no, when you turned on the
maybe.
cameras, it wouldn't let us unmute anymore.
Yep. It's either way, right?
Yes, either way. My sign language isn't quite up to scratch. I was going to start
I was
typing
signing to
overlays.
my mic, yeah.
Sign language, that's funny, yeah. Sometimes that's useful.
Yeah, so it's right now I'm still experimenting with it. It's, where is it? Fluentvalidation.net is kind of the package that I started looking at, that you can start building out these rules to say that, this arbitrary object in C# and start adding rules to say, oh, does it have this property? And start chaining down and say, is this an array? Is the array empty? Does it have that value and things like that? And so you can evaluate those at runtime. And so that's where I started thinking, oh, can we map essentially the core FirePath/invariants into that type of thing. So then we can say, oh, we can run all of those very easily at runtime without loading anything else. And so that's kind of where I've been playing, but I'm still finishing up all of my other playing on profiles. So
is that an existing third-party library?
Yeah, yeah. If you go to fluentvalidation.net, it's 80 million download NuGet package for C#. And I came across it because someone else is using it in, validating whatever random things come in that they needed to validate on some other project.
Right.
And so it's yeah.
I did, from the onset use the because .NET has property validation, right? Of attribute validation, attributes-based validation. So we did add that to the stuff. So this doesn't need to integrate in the class. So you can use this on any class that you don't manage, right? That's the difference. Yeah. And what does the rule set look like? Is that a kind of scripting language, or you write the rules in .NET?
It's in code in C#. So it's literally just you do like rule 4, and they have an example up on the main page there. And it's all open source on GitHub, which is the other plus.
All right. Yeah.
But it's
Is it also a Java variant of this? Because
Fluent, it's the Fluent style of that's a pretty common pattern overall.
Yeah, because I did some Java project in the past a few years ago, and I think I used this.
Oh,
exactly.
Wow.
That's so familiar.
Yep.
Yeah.
And that's kind of the benefit, is then you can start saying, oh, it becomes easier to port, if we can sort out mapping some of the FirePath and invariant type rules, then it becomes trivial to let people extend it further in the future and things like that. So, but yeah, I'm trying to finish up my profile code stuff right now first. Unfortunate. So it's next on my list.
Yeah, well, that's interesting, because the element schema that I referred to in my talk is actually also just a rule set. So we've split up the whole validation in 2 steps. The compiler, which is part of the car compiler, it takes a structure definition and puts it into validation rules.
Mm-hmm.
And those are the rules that you would run like a zillion times then on the instance. And the major advantages is that you're not rereading the structure definition all the time. And there's a clear separation between errors made by the author of the structure definition, because you catch them at compile time, and errors in the instance, because those are merged now in the current validator, where people will get errors about stuff that the author of the structure definition actually made. And the puzzle that Marco and I have to, because we basically ported most of the current validator into that, but the next step, what we'd like to do is add the validation rules that are now buried in the typed element and source node, because they're the validation blocks too, and that would enable us to finally, have a configurable set of rules. So if you want terminology validation, you produce a set of rules with validation in it. If you just want structural validation, and so we could define a set of rules that's exactly compatible with our current parsers.
Yes.
Or a smaller set, and that's the end game, right? That's where we want to get to, because we all know that currently what we have with permissive parsing, it's either true or false. Well, we discussed it with all of us, I think, before, but instead of adding more and more options like enable this, disable this, enable this, I think it's better if we go this rule-based compilation. Seems like this Fluent stuff could fit into that. It's probably, I'll have to check whether it, Marco, if you used it, you're the expert here.
Oh God. Well, it's a nice way of setting those validation rules up, I think, and it's also in a more readable way. That makes it.
Yeah. Especially as we move towards IGs being more popular and widespread, and then building on top of them, that you say, yes, I need to validate against the core spec, and I need to validate against this IG, but also in my workflow, I'm just doing this other thing, and I want to add the similar type of validation. as you start solving those higher order problems, some of these kinds of things that filter out, I think, are interesting problems. So I probably spend a little too much time playing, more than I should. But
well, once you're into validation, you can't get away anymore. Yeah. Well,
the other space I'd like to see a little more effort go into, certainly I'm putting a little bit more effort into it myself, is around the actual error messages themselves.
in the validator, you mean, Brian?
So around being less profile user friendly and being more consumer friendly.
That's what we also try to
And
do
so
in the
I think
validator.
that same technique sort of then walks into the whole translations and multilingual stuff.
Yeah,
and not that I have any need for that, but I know.
Yeah, but other ones have.
Yeah.
It's on our list as well.
Yeah, I think we compiled, maybe actually, Brian, you helped it too. And I think you saw that list of the kind of, it's on the wiki in the .NET SDK, I think. We have a document about what kind of requirements we'd like for our error messages. All of them almost mean that we need to have some kind of templating in the error messages, right? Because you want to have it in German, you need to have like lower limit. If you're producing a cardinality error, you want a German with some placeholders. Don't think there's a way around that.
Yeah, string tables and everything else that you start shooting in.
So yeah, with my questionnaire validator, I've got a large chunk that actually has all of the error generation in line. Well, not in line, it's as a set of functions. So when it comes across the error, it calls the function to generate the part of the output, so that I can just go and replace those, and it's got the error codes in it. It's kind of, you do almost have that in the core validator. Certainly, I pulled the inspiration from there in terms of getting the single code. The other thing I added, which is the only reason my current validator package is forked still from the Filey one, is I inject the invariant ID into the outcome code so that I can actually pin this error message came from that profile and that invariant. So that's the only reason I've actually got a separate specification project.
Right. Yeah, because at the moment we validate the firepath statement, obviously we do have the ID of the invariant, but it could well be that we don't output it into the output string, right? Because we squash everything into an operation outcome, which probably doesn't have a space for this, or we might find a space for it, but I don't think we do that yet.
Yeah, I put it into the code. So you've got the code value that you use. I just add another code in with the system being the profile that the invariant was from, and the code is the invariant code.
So do you use the codable concept there, which can have multiple codes? Yeah, that makes sense. Yeah.
So it's just appended on the end. So if anyone was expecting to use the Filey system, it's there still. But yeah, otherwise you've got.
Yeah, that's interesting. The error structure that we build up actually has something we call evidence. So you report a certain error, cardinality incorrect, and then you have 0 to star evidence, and one of the evidences would be, or if you run a firepath statement, obviously the firepath ID for the invariant would be the evidence where this failed. But in our translation to operation outcome, I think we drop most of that. So we could certainly do that. But I think, Marco, we've delayed this discussion until after DevDays. Is the priority for the next steps in our validator. Before DevDays, we got it working in some kind of beta version, and with our partner Black Pear that I mentioned.
Literally 1 week before the DevDays.
1 week before, we got all of this working in their AWS step function. So that was like a small victory. Started this car compiler in December, so it was all in all quite a bunch of work. But after DevDays, we will continue with the validator. I think bringing it from beta 1 to beta 2, and error messages could be one certainly one area. What we've done, and actually, well, Graham did a lot of this work first. Is Graham has written it's a JSON file, right, Marco? He's got like 300 or 400 unit tests now, and so his output is in there.
It's a manifest. Yeah.
Manifest, and we have the output of the current validator. And that's now in the API, in the 2.0 API or 3.0 API. And we have our new output. And now, so after DevDays, we'll start comparing and see if there are
comparing
any regressions.
our old and or our current validator and new validator, and also the validator what Graham has.
Yeah.
Just to get those differences out of the way. I have to leave because I have to go for Josh moderating.
Oh,
okay.
Yeah. Good luck moderating that, Marco. Thanks.
Okay.
Thanks.
Bye.
Yeah.
In the lead up to DevDays, I had a few things that I'm like, oh, I want to ping, and I'm like, you know what? I bet they're really busy before DevDays. So I'll try and catch up at DevDays.
That is always a good idea, because after DevDays we're like, okay, so what's next? So that's the perfect moment. So that's why I pinged you, Gino, like maybe we should pick a moment after DevDays to chat a little bit. I got loads more ideas of inspired by your where Al talks about making the parsing more performant, or allowing people to write more performant parsers. I don't know, but then that the output at least can be input to the validator and the firepath engine and so on. And
yes.
Actually, I'm thinking about, now we have a good code generator. Thanks again for that, Gino, that we could generate code on every POCO that implements iDictionary. So the name of the elements and the values, and I could rewrite the firepath engine and the validator to work on iDictionaries, which would work beautifully for unit tests. But it also means that whatever POCO you do, as long as you implement the pretty well-known iDictionary interface, you could run it against any of our components. And it's what we used iTyped element for now, but iTyped element has all kinds of definitional data that I really don't need for most things, funny enough. If you give me the root type, I can just follow by element where we are, so I don't need really to have that repeated in every single element. And that's really hard to implement currently on the POCOs. So Brian, that's why we have the POCO nodes now. And we could skip that whole layer and all the memory and all the objects that creates when these objects would just implement iDictionary. And you don't need reflection either, because you just generate, if the key asked for is blah, then return this property, and without needing any reflection. So that could speed things up also quite a lot, I think.
Yeah, it's interesting to think about all the weird things that you can do, because you're generating the code that generates the code. And then it's like, oh yeah, we know, all the type information, all those things. If we know those at the time we're generating the code, then we can take a lot of shortcuts, because we don't need to load it at runtime, because we already knew what to start with. So
yeah. Even for situations like that, what I'm thinking about in the car file is, and what I have already in kind of beta, I started encoding the core data types, in a very efficient format for the car files, and it was comparable to what we have in structure definition summary. I don't know if you've ever seen that one that basically describes, and I was like, why? And I needed some extensions on that, but it was getting closer and closer to system.type. So I was like, why am I not using system.type for this? So our car file compiler actually takes a structure definition and emits a DLL with this type encoded as types. So it's just like the POCOs, but every getter and setter will just throw, because all I need is really the attributes on the elements, and that's all I generate in the IL, and then I include it in the car file. So when I want type information for patient, I'll just use reflection for it.
Nice. Yeah.
That's one of the ideas. I mean, I'm piloting it.
Yeah, that's pretty fun. No, I'm thinking through it since I missed part of the talk for a call I had, so that's why I'm like, oh.
Yeah, I didn't put any of this in the talk. But as I was rethinking about very, quickly deserializable formats for type information, it was like, my goodness, over the past 20 years, the .NET guys have been working on the reflection and getting it serialized to a DLL. What am I doing? Just load the type from an assembly. So even if you don't have the classic generated POCO assemblies that you generate, you can have these on-the-fly generated lightweight DLLs that still contain all the attributes. And if we could generate them for CDA, you call this car compiler, it will generate them for any of your models, and we would have type information available.
Yeah, and especially with .NET 6 and the ahead of time compilation, things like that, there's a lot of performance improvements that you get kind of for free on all
exactly.
Those.
I was like, I can't beat those .NET guys working on this for so long. What am I doing? Why am I replicating their work? What opened my eyes is that I actually also needed meta information about conversions, right? I really need to know that a Fire Boolean class is represented in FirePath as a system Boolean. And we don't have that information right now. So it's hard baked into the .NET library. And I hate that, because for CDA, this isn't true, right? It doesn't work that way. So I was like, oh, if I could just, what would people expect? Well, it would be nice if you would take our POCOs, create an explicit or an implicit cast operator there, and voila, the FirePath engine would know that you could cast this to a Boolean in FirePath. But I needed more type information for that, and I was adding that to structure definition summary, and then I was like, no, this is not the right way to go. All of this has been done before.
The emit stuff doesn't work in Xamarin, in the Apple and the Windows Store apps.
That's right, but the good thing is that only the platform that you run the car compiler on needs to be able to do it.
Yeah.
And worse, actually, the newer .NET stuff that I'm using doesn't have assembly builder.safe. You can't actually store a dynamic DLL anymore, which you could in framework 4.6 and 5, but .NET Core hasn't copied that because it's obviously, or they said it's really, really hard to get that code across, especially the debug stuff that's probably injected somewhere there in the code generation. That was Windows specific. So they haven't found a way to save, to actually save the bytes, a DLL from a dynamically generated DLL in memory. Luckily, there's a very crazy, it must be crazy. There is a guy who developed a third-party open source library that does that. And I looked through the code, I'm like, oh my gosh, generating, he is generating low level, all this .NET DLL, low level byte format stuff, and he actually does that. But there are obviously huge bugs in his library, so I can't do everything. For example, one of the attributes, I think it's the reference attribute that we generate, has a list of types. So in the generated code, it looks like type of A, type of B, type of C. He can't turn that into a DLL. Probably his use case didn't use that bit. But maybe I have to turn to Roslyn. I could do that too.
That's pretty soon. You're just going to have a compiler, and that's it.
Yeah, that's right. That's right. The compiler is there all the time. So the car file compiler could just produce using Roslyn. Instead of using ELEmit, I could. But then I'm replicating your work, So.
Yeah. If there's a better way to do it, whenever there's a better way, that's yeah, that's the goal, is make it better. So
yeah,
you come up with a better approach. Like, let's take the better.
And I think we're currently all searching for ways, because we now have some experience generating code, working with Fire, and we know the POCOs are 10 years old, and so I know that there is. So I think something like this iDictionary idea and the fact that I can reflectional type, I think is really powerful, because it just goes with the framework. I use whatever is already there, and it also means you can go wild and create your own JSON parsers that that deserialize to something that is not one of the POCOs in .NET. As long as you implement the iDictionary on it, you can still use it.
Yeah, the extensions I have, it's the same thing. As long as you define the extension class you need, you can just do that. But every field is broken out. I didn't use the iDictionary idea, which I kind of like, and that's, yeah. I'd be curious. I'm curious to see the actual difference performance-wise in doing it one way or the other.
Me too.
Can you just explain that one as well? Like, so the iDictionary you mean is like the child elements, or just the properties that you didn't use or did use?
Yeah. So every POCO would implement iDictionary string.
Yeah.
Comma object or iDictionary string iDictionary. I would have loved union types here, so I could just say it's either an iDictionary or one of the primitive fire values. But there's nothing we can do about that. But that's it. Yeah. And so basically, you would implement hard code if the key is field X, you'll just return field X, the property X, right? So we would have really low overhead because you don't use reflection anymore.
Yeah, the complementary piece to that, which I was thinking on building out but hadn't gotten to, is saying define an interface for the primitive types. So that you say you have a factory or something that can generate your serializers and parsers for each of the primitive types, because all you really need to know is either for parsing, take in an instantiated object and put it into the right field, or conversely, pull it out, you just need the fire field name. And so you can actually generate those interfaces yourself, and then you could tweak your own parsers and serializers that just take all the primitives and do all those things.
And would they be able
the named children stuff already, which is just enumerable?
It's very close to what iDictionary would do. Yeah. We're already generating. We are already almost doing it. It's just that when we created this what was the name again, Brian? Enumerate children or whatever it's called.
Named children.
Named children. I was not thinking ahead quite far enough to say why not go all the way into iDictionary. And I don't know, Gino, if your idea the other way around. Is that integratable with the idea of even implementing add on iDictionary to set values and deserialize that way, or?
It should be, and that's why I'm trying to think through on what it would look like.
Yeah, me too. I've been puzzling about that for the past few weeks because you need some kind of factory method to be able to add something.
Yeah, what I did to build out like the current one that I've been working with, I started with just taking a project that's using the POCOs and building out the extensions by hand. And then what I actually did is added another language to the code generator that builds all of the equivalent Firely structure in memory. So it doesn't output all of the POCOs, but it gives you all of the trees of, patient, and then it has the name component and all the elements named the way you need them and everything else. So then in
which format is that? Is that in an interface? Are you saying that, or?
No, yeah, that's in. So that's in the language I added to do these extensions. So.
Yeah, you're doing the extensions as they just added. What did you do?
So they're in the dev branch of the code gen. And it has the generated, I checked in generated. Yeah, there's a generated so you can see what the output is.
Oh, let me see. Let's go gen. Let me get to the right branch there then. Oh, I'm in dev, the fire go gen dev, yeah?
Yep.
I have that checked out already.
Oh, there you go. So if you look in generated, there's a folder system text JSON extensions for R4.
Let me see, generated. Yeah, and system text JSON ext R4, right? Yeah, yep. I got it. And then?
So then if you go into model, for instance, you can see this mirrors all of the Firely model names. And if you click on inside any one of those, the code that it outputs knows the Firely POCO name, traversing backbone elements. It has all of the value set enums. It knows all of that. So
now I see what you mean. You have these are not Fire extensions. You generated .NET C# extensions.
Yes, C# extensions. So there's
extension
actually
methods to do a
Yeah,
getter and
Extension
setter, right?
methods. Right.
exactly.
And
So
then that doesn't have a property itself. It writes into the extension set.
exactly. So this you can just load at runtime in your project, and it just lays on top of the stock NuGet package.
See, this would be if this would be a wonderful fit for the iDictionary approach.
That's exactly where I'm saying, like, oh, if we clean that up, and instead of there, for instance, in every function, since I know the type, I directly write, write Boolean value or things like that. Well, we can just put those in functions, and if we build an interface file to say, here are my setters and getters, essentially, for when I want to serialize and parse, there's only 10 functions, 15 function profiles that you would need to implement, and that would cover all of serialization and parsing, and then you can do it into, add a setup and a teardown, and you have plug and play serializers and parsers that people can play with. So yeah, if you look in the languages, I added C# Firely to JSON extension.
Do you want to share in the chat where that is, or share the screen?
The chat's not up.
Over in Hoover, unfortunately.
Oh yeah, I can share my screen.
Unfortunately, or sharing screen.
Yeah. Can you share your screen here?
Yeah, I'm setting all of that up because
who can share? Only host. I'll set it to all participants. So they made me host, obviously. So I enabled it for everyone now.
Nice.
Yep, that's why we did that.
Yeah. Oh, thanks. Yeah, that's wonderful for these kind of occasions. Thanks.
So if I do this,
is a familiar view.
Yeah. So in the language, and I don't have the project open right now. If not, I'd use VS or Visual Studio for it, which is a little easier. But this language cheats. So when it starts, it's using all of the Firely common things and everything else. But then it goes through and does all of the complex types and everything the same way Firely does. I think I can navigate to that. Write complex data type, this one. So in here, it's just going and building out the same name for export, everything else that you do when you're generating the code, but then it doesn't actually export it. And that way I build these dictionaries and I can write these extensions using the same name structure, everything else.
And how did you fix the silly thing we put in the Json serialization where you have this name and underscore name stuff?
It's kind of annoying.
I know.
I won't lie. Here, let me.
By now, I have written three deserializers for the JSON. So
yeah.
It's always.
Let me just go into
especially these arrays that have to have matching elements and so on. It's just such a pain.
Yeah. This is easier as long as I'm in the right branch, which I have no idea which branch I'm in right now. Give me a second. And I am in dev. Outstanding. So in the exported code, you're saying for when we're parsing things?
Yep, this is parsing, yeah. Serialization to JSON is the easy part. The parsing of JSON really sucks.
So yeah, the code that does that is pretty frustrating. I don't even remember what I was working on last time I was in here. So the big ones are, you want to look at serializing or deserializing?
Deserializing.
All right, so deserialize. So internally, this function's in the code gen still. And so we figure out based on the CS type, current name, fire element name, it's a pretty straightforward set, and it didn't actually need his choice. So I'd remove that. And so when this is called, it's actually keeping track because the external one knows what it needs to do. But then here, we're just checking to see, where is the actual, you can see it outputs all the things for the arrays and everything else. That's why looking at the generated code is a little more straightforward for that, I think.
Yeah. Well, you don't have the generated code?
Oh, yeah. I have the generated code.
I mean, to understand the generator, most of the time it's best to first understand the generated
I think
stuff.
this project is probably the easiest to
Which
look
was the branch that you're on?
It's on dev branch. Yep.
Yeah, cool.
So this is the serialization benchmark project.
Oh, that is outside of my screen.
Yep, I'll bring it back in.
Yeah.
Lovely.
Not updating right now. So let's see, the core thing, let's see if there was anything. There's the utilities, there's the resource converter so that you can do the polymorphic deserialization and everything. So this is just keeping track of the different types of resources and serializing or parsing them properly. And again, that's where the code gen stuff is much more fun. Internally, it does check, so when it's parsing things, if it's looking for instance, the resource name, because that hint has to be before you can learn the type. So in here, we actually, if it isn't resource type, we create another memory stream and re-encode the JSON as we go until we find it, then back up and parse until we hit it again, and then continue on.
Yeah, what else can you do?
I'm sorry? Yeah.
What else can you do?
The only other way is, and that's one of the big performance hits in general, because generally the resource type is first. But if you use a document parser, because that's how you get around it, that's what the current implementation does. That works because it parses the whole thing first, but then you're losing performance because you're parsing the whole thing first.
Sure. Yeah. But
so,
I must say, whenever I was thinking about rewriting it like you did now, I was like, oh no.
Yeah, it was pretty frustrating. Luckily, JSON doesn't have too many different token types.
No.
So it's pretty straightforward to do all of that. But then if we look at, for instance, patient, you can see if we want to serialize, because I think that's what we started talking about. You can see this is literally just coming through and figuring out this is the generated code. The first thing is, we're checking to see if we're supposed to put a start object when we're writing this object or not. Include the resource type, that's automatic on anything that is a resource from the code gen. Same thing, it knows if it's an inherited object and it knows to promote those. So in this case, it's saying use the domain resource serializer.
Yeah. Right.
And then it's just checking, and these checks are based on all of the type information. So in this case, it knows it's a list. And so we're checking to see if there's the identifier and if there's more than 0 elements. And then all of this is based on the type. So
is this working with the new 3.0, I think the 2.0 branches as well?
Yep.
Okay.
This is running, that's in this project, I have, what's in here right now?
There's actually not much difference between 2.0 and 3.0, but
this is running 3.2.
We decided to be honest. We had a very, very small breaking change in 3.0, but it was a breaking change, so we just called it 3.0. Yeah. From 1 to 2.0 is a bigger step.
Yep. So you can see here's a good example, like current deceased, we know that there's the element deceased. We check to see if that's nulled. And then since we know it can have multiple types, since it could have the Boolean or the date time, it generates this type-based switch statement. And if we find it's a Boolean value, go and write the Boolean. And then since that's a primitive, check to see if that has extensions or an element ID. And if it does, then go and use our helper function to serialize a list of extensions under this property.
Right.
And then it does the same thing for date time to say, well, that's the other type it can be, and go through and do all those things.
What if they're both there?
It can't. Deceased has to be one type or the other type.
I know, but I've been testing patch, and if with patch I can basically add the other one, which is an invalid document then. But the current parser actually tells me it's like you can't have 2 nodes, which is correct.
Oh, okay, because we were looking at serialize. So now you're saying if I'm deserializing and they're both there. Let's see.
Deserialize, it's the same element, so you can't. There's nowhere in the storage in the object model to have 2.
not in the
Yeah.
Pogo, but if I patched it in with like JSON patch,
True.
I can force it in there.
Yeah, but you can't. So what happens is here, there's in the JSON, they're labeled differently. One is deceased
Yes.
Boolean and the other is dates time.
Yep. So I end up with
Date time.
Yeah.
So here it'll just read and you'll
The
just
last
get,
one would win.
you'd get the last one here.
Okay.
So, but those are the kinds of things where you start saying, well, if we put something that reads choice types and or the Booleans or different things like that in an interface, then if you are doing very bad ideas like directly patching JSON, you could add your own tests to handle those.
Well, this was one of the scary scenarios that I felt that is available with something like patch is like, and this is the exact one that I was trying to test, right? Like if you had deceased as a Boolean, and then I'm like, well, hang on, now we know the date time. I just want to patch that in. Now I've got two nodes, which is just one node, but it's a choice type. What happens?
Yeah, it hadn't come up. It's not too difficult to add. Like here, we could easily figure out, we know that this is a choice type. And so we could add a similar check here to say, you know, if current.deceased is not null, throw
There we go.
new
Fixed.
exception. Huh?
Fixed. All right.
Yeah. And so that can easily be added to CodeGen. And so it's just a matter of saying, okay, well, yeah, adding those, it's a tiny performance hit, you know, and that's why I wrote the benchmark project, is so that we can evaluate some of those types of things and see what happens.
Yeah. So my project is, I'm just comparing on the screen here the XML equivalent of exactly this, and they are almost identical.
And that's exactly it. That I think as we're building all of these things to test, at the end of the day, there's really only, what, 10, 15 functions that we need to actually handle. And all of those could probably just be in an interface. And if you implement them, you have a serializer and parser, and we don't care about the format.
Yeah.
And that would enable a lot of runtime playing with things like, I know Ewout and I were talking about Protobuf the other day and things like that. You wouldn't have to build out all these other things. You can just say, well, how do I handle each of the primitive types and arrays and, you know, some of those types of things. And I think it would work.
Yeah. Yeah, mine doesn't do any throw exceptions like you've just dummied in there. I call a handle property error, which then goes and does all of the operation outcome magic.
Yes, and I've been looking for a link to look at that because I wanted to put that as an option, and I could not find your project. And so I was like, oh, it would make sense to generate the same thing. It's pretty trivial to actually
it's on GitHub.
Yes.
So
what
were you referring to, Brian, for the errors?
So my XML parser's done that step, and I've got the outcome part.
Yeah. And so like here, you can see here's the one, like if I'm trying to read address and I get a start and I don't get a start array, right now it throws saying, you know, patient. So that's the object I'm in. Error reading the address field, expected start array, found whatever the token type was, depth, position in file, all those kinds of things. And so putting those in an operation outcome is trivial. I made sure to bubble all of those things up, but I didn't want to invent a new format if you already had one.
Yep, here we go. I'll drop it in the, unfortunately, the chat on who, actually I'll put it into Zor.
Yeah, because the other fun thing is I have, for instance, and I should turn it off for the ones we do, but in addition to the normal converters or formats and whatever, I have a debug option. And actually, when you turn that on, the serializer and parser write every element as they're parsing and serializing to say where they are. So if you have a problem file, and that's why I added the flag, if you have a problem file, then you can, there you go. If you have debug on, it goes and tells you like patient.contact components, reading patient, hashtag contact, that property name, the depth, the position, everything. So it's easier to go and debug that in individual files. I don't know that it should be there, when this ships, or if it does, it needs to be cleaned up.
Yeah, so I've put that into mine as well. Basically the same. I've used the location field for that, and the full path I've got in the expression.
Yeah, the deprecated location field.
That's correct.
Yeah, that's correct. That's correct. I mean, that's also a bug on the API, because we generate the operation outcomes in the validator also in the location, and that's not so one a practical, well, so I love doing any of this. The one thing that is nagging in my mind is that the current parsers, of course, have a set of structural validation rules that they catch and some that they don't, and an exact text for what they're outputting. If we would start using these deserializers, we would get probably a different set.
There is, in fact, I had forgotten, I was typing up that reminded, when we were talking about this, it reminded me that I needed to file the bug. There's a bug in the Json Serializer, actually, in the core one.
Okay.
That you're not supposed to trim white space except on the code type, and right now it trims on all of them. So in XML, you have to trim every string, but in JSON, you're only supposed to trim codes.
Really? I didn't even know that.
Recommended.
It was
I've done
very
the same thing.
It was very poorly documented, and that's why I knew about it, is because I brought up the issue, and we had it just resolved at FireEye a couple weeks ago. That that's what's supposed to happen, and it's actually a note we want to surface about XML, is saying if you're using XML, it will be trimming white space, and so that's kind of scary in some cases from any text field.
The other one, when I was going through mine, is that the current serializer does, in the XML space, does all that XML entity resolving all of that stuff for the whole thing, when it actually only needs to do it on a handful of properties. And so that's a lot of overhead and a lot of string manipulation. So now that's only
right.
one property.
Yeah. But so how, say we say to our users in .NET, in the library version 5, we have a whole set of new parsers, use them, and they will probably come back to us saying, hey, but I'm getting different errors. Is there anything we should be doing about that?
I don't know, and that's why it's in the dev branch, is I wanted to be able to play with it and start exploring these things, but
right.
We're already getting those issues.
I'm all for getting more efficient parsing, so I really love all everything you're doing here. But we could easily just say this is version 5.0. We're breaking stuff. We're breaking the parsing. But you know what's going to happen. I recently fixed a bug where it was just really a minor thing with parsing date times, and before we allowed date times in dates, and now we didn't do that anymore. I think that was one of Brandon's colleagues. He's completely right, but we'll get tons of those errors when we completely overhaul the parsing framework. So although I'd love to, I'm a little bit afraid of doing it.
Definitely, and that's why I like the extension thing, at least to start with. Because to me, it's like, hey, this can lay on top of it next to it.
Yeah.
You can use it or not.
That's right.
And as we start moving towards more options, then we can start saying, okay, here is the, standard, or whatever we want to call it, that you're used to, the V whatever we want to call it, and then we can start layering these things in next to them to suit people's needs. Because, for instance, I haven't implemented summary on this yet, summary or elements. It's trivial to do. I did it in one of my test ones. I just didn't do it in this version yet because I wanted to get more feedback.
Yeah, the only thing about non-trivial about the whole the summary stuff is like, or that is all, some of these summary formats, whether or not it needs you to include mandatory elements, even though the parent element isn't mandatory, but when you do include it, you need to include the mandatories. There's tons of stuff about that where we're like, oh my gosh, that's also poorly documented.
Yes, I did file an issue because I did that when I was doing that test of the summary and elements, and I realized the same thing. I said, hold on, this is incorrect.
Hey, Rick.
Hey, guys.
Hello.
Hey.
I'm just
and so I
looking.
did file an issue for clarification on the proper behavior because every server did it differently.
Right. So like I think that also something like mandatory extensions are not in summary or something like that. I'm like, really?
Yeah. And once you include an element, you're supposed to include the entire tree underneath it.
It looks like it. That's supposed to happen. Yeah.
Exactly. But that wasn't clear either. And so some implementations did and some implementations didn't.
Yeah, the Java ones does. So I think Marco for 3.3, well, there was a bug filed against the 3.2 API exactly for this. I think there was also one of your colleagues, Brendan, Ivanov, or I don't know his name exactly.
Yeah, probably Ivan.
Ivan, yeah. And so Marco has fixed that, but it meant including everything. And that's what the Java one does. So we were like, okay, so if the Java one does it, we'll probably just follow suit. It's not clear from the spec, but let's just do it.
Yep, makes sense.
So I think that's
The
fixed in 3.3.
agenda's moving on, guys. I'm going to head over to another session.
You're perfectly fine.
Yeah.
Good. Thanks for visiting, Rick.
Yeah, it's good to hear you guys talking Turkey. So I was just, trying to absorb it.
Definitely.
You know, Rick, that I'm still sometimes thinking about the Greek meal we had in London, I think, where by the time the main dish came, we were already like, here, like.
That was insane. I needed them to stop bringing food. It was embarrassing.
Oh, man.
That was hilarious. And that bar we went to, they knocked that bar down now since that really good real ale bar, Brie Louise. They knocked it down, so there's no more. Too bad. Progress.
Well, I guess I hope we can have these kind of encounters again. I really miss it.
Sure.
Yes.
All right, folks, I'm going to look at provenance results over in a different thing. See you later.
Bye-bye.
Rick.
It's interesting, Gino, that these are a lot of the subjects that I was thinking about talking to you next week about, because I saw your implementations. I was like, oh, and I know that. Well, another question was, I know that Brian was doing more or less the same thing on XML, so it's actually very, very timely that we are now all here in this call. And if we need, so maybe also if we need to go into more detail, we could extend. I don't know. Did we pick a date for next week, Gino? But we could easily include Brian and Brendan if we. No, I don't think so.
I don't think we did. I don't see one.
No. Maybe we just agreed that we would do it next week, but we haven't picked a date yet.
Because it does.
Yeah, a lot of ideas that I'm having, and you and Brian, it would be a waste if we publish them separately and incompatibly.
Exactly. And that's why it's interesting, because the same thing, like we were talking about the operation outcomes, returning those. I think that's great because it gives you a lot more option to handle it. And then I was thinking, and we can also do fun things like that decimal one. That one drives me crazy. The decimal test that we don't pass because it's out of range.
Yeah.
And it's like, well, you know what? We could parse it and then put some extension saying, here's the string value or the raw value or something, with a note saying, yeah, this was out of range. We can start adding those types of things to say, since we know we were parsing a decimal type and we know all these things, we can start adding specific handling and specific annotations and things like that. So I thought it was interesting to think about.
Yeah.
We can keep building those things forward. So.
Yeah, for sure. And this is all because now after 10 years and Brian almost 10 years, I think, on the .NET API, and I think we all have our IDs on. And I don't want to make a move I don't mind changing the SDK public interface, but if I do, I find that I'd like to move somewhere that we all agree on, because most of what's in the API now is most of the things I thought up all by myself because there was no one else to talk to. And so some of the problems in the public interface are all mine, but
well, you're being hard on yourself. There's a lot of great, and especially the decision you make, yeah, you made a decision saying we need conformance, we need flexibility, we need all those things. And it's like, okay, yeah, 10 years later, yeah, the needs change, and that's software lifecycle. So
yeah. That became clear. Well, that's why we're still in this talk. When we rethought the SDK for use within the cloud, and quick cold starts and the whole conformance mess, I was like, oh, we need to revisit quite a few things here. And Brian keeps saying, I thought we had that before, that memory and compute power was cheap, but now you pay for every single byte. So everyone is like, oh no, you can't make, just don't make too many objects.
Yep.
Don't use too much compute. My credit card hurts. So it becomes interesting again to look at efficiency, and that makes sense. 10 years ago, it just had to work, and now it has to work performantly. So I don't mind at all reviewing parts. And I think if we can go outside with a breaking interface, or maybe as you're doing it, saying add additional parsing methods, and say, these ones are way more efficient. The old ones will stay around for a while, so you can still parse whatever data is in your database. But here's the new set. Maybe that's the strategy we have to do. Well, and we have to keep both around for a while. And at some point, maybe in some version, I'll say, well, let's kill the Poco builder based stuff, because we don't want to maintain that forever.
Yeah, because my original thoughts were, we could just have a way to swap them in and out. And then I thought, well, where do I go and put that? The only place it really surfaces is in the Fire client classes itself.
Yeah, we discovered that last time.
In the servers and everywhere else, you're doing it manually with the classes, so you can pick and choose which one you want.
Yep.
Certainly inside our server, we'll have one that reads from disk, which doesn't need validation because it's been done on the way in, so I can just get it off as fast as I can. Whereas on the way in, I want to be careful and make sure it's right before I put it in there.
Right.
So it's also important as well, because everyone that is running a Fire server, you need to get the data out. So after it's in there, it needs to come out. No matter what happens in the future.
Yeah, that's why I think this continuum of executing these rules from almost nothing to complete profile validation is worthwhile, because you'll run the full stack when you get external messages. But as Brian said, once they're in your storage, you validated them, and so just get them out as quickly as you can, and as quickly as you can.
No point throwing an exception while you're trying to read it off the disk.
Yeah, and as quickly as you can probably means other kinds of deserializers, or in fact, we hand wrote a message buff what's it called again? Message pack serializer for I-typed element. So once I have an I-typed element, we can serialize it to binaries in the car file, and deserialize it pretty quickly, so we don't need to parse the XML and JSON stuff. So that's even faster. It's like binary JSON, right? Once we've parsed it, but the same would be true if we go for the iDictionary approach. We could write a very speedy iDictionary serializer. There are tons of them, actually. Almost all of the serializer libraries can serialize iDictionary out of the box. System text JSON can, Newtonsoft can, message buff, I guess Protobuf can.
Yeah, and that's why you just need to add all the custom handling around it, so that you say, don't just serialize the object as a generic object, use this serialization definition and things like that. Because that's the
for all of these deserializers, the interesting thing is deserialization, because you can deserialize a dictionary, but when you have to create an instance of a child dictionary, and you create a dictionary, no, I want you to create that dictionary. And system.text JSON isn't there yet. It's early days for system text JSON. Newtonsoft was a bit more flexible there. But luckily, I've looked deeply into system text JSON now, I must say that. But I find myself, I need to write custom converters all the time. But at least it's possible.
I just built it from the ground up saying everything's custom, and I'm using the raw read Boolean value, write Boolean value, things like that, because that was just easy.
And
luckily, that's blazingly fast. Yeah. The good old XML reader, Brian.
Yeah, nothing wrong with it.
No. I know.
Actually, there is one thing wrong with it, but yeah.
So I do have a question while I have this particular group. Let's see if I can share this again, and it works.
Maybe we should get this part trimmed off the recording.
Oh, probably. So I've been playing, like I said, I've been playing with profiles and extensions. I realized that using profiles and extensions was very painful as a developer. And so what I've started, and I'm playing with this, and then I want to generate C# class extensions the same way I am for the serializer, but essentially creating these overlay objects. So like here I have this class that's a US core patient, and you can see like, oh, you can set the profile. So it's a static extension on patient, and you can, clear, or you can look for specific extensions. US core birth sex, it goes through and it's just looking at birth sex and translating the codes back and forth.
I saw something very similar on YouTube just recently.
Yeah, that's my excuse as I'm working through it. That's what actually caused me to say, oh, I need to generate all these things. But I don't assume anyone's watched any of those because I don't watch them.
We watched them.
Oh, well, there you go. So then you can see I'm just doing like, I can just say patient.US core birth sex is female.
Right.
And it generates all those things.
Yeah. Don't you love extension methods?
I do. And that's why I'm just curious what people think one way or the other. Is that a worthwhile endeavor? Is that the kind of thing? Has anyone?
This is what I would do.
Things?
This is what I would do. Yeah.
That's what I actually recommended and have a blog post to say if you want to do custom stuff, that's what you should do. Don't create a new class derived from patient. Do that.
Yeah, because what I realized is the code gen, and I think I've made most of the changes, it can read profiles just as easily as it can read the core spec. So I could have that generate.
Except for the slices, of course, because you'll have duplicate keys if you don't watch it.
Well, and that's why, however you would manage it in code, I should be able to write an extension class that does the same thing. There's obviously a performance hit if it's going and traversing, looking at everything else. But if the extension classes themselves don't keep track of anything, and it's just always accessing the underlying objects, I'm hoping that prevents having those types of problems.
Right.
So something like, here's my social security number, patient.US social security number.
Exactly.
And it just goes into the identifiers collection, finds the right system value, and then reads the value.
Exactly.
Sure. Yeah.
Yep.
Yeah, and I think the Google guys did something like that. Some of they recognize some of the slicing structures to be simple, say, selectors for certain kinds of identifiers. So you can expose a Dutch BSN identifier, which is actually a slice on identifier with a very simple discriminator. And they recognize those patterns and they create properties for them.
Yep. That's exactly.
We could do that for a subclass, obviously not for all slicings, but we could do that for a subclass of slices where it's simple, identifier, where there's a simple slice on the coding system, right, of the identifier, and if the identifier is some kind of fixed code there, you know that it's a US social security number.
Yeah, and that's why for things like position, things like you're saying, the simple matching, things like that, I think it'll work pretty straightforward. I'm scared to see ones that are like, oh, based on profile, like, oh, that's going to be painful.
Yeah.
We'll see where it breaks.
Yeah, and so an additional complication here is that POCOs obviously can only read correct data, right? There's no way to represent POCOs with extra fields. So when I was thinking about this whole iDictionary thing, I was like, or we could have like the base elements plus a dictionary for stuff that comes in that's not part of the properties. So you can stuff an element that you don't know about in a dictionary. And if you implement iDictionary on top of the whole thing, you could say, okay, these are my hard code generated ones, and if I don't know about them, I'll pull them from my internal dictionary.
I also prototyped this exact thing as well.
Yeah, but
Yeah.
you're actually duplicating. You're getting this for free and more if you subclass, I think, expando object or some of the dynamic stuff. Expanded
There's
dictionary.
The two I've used has been just shoving them into the iExtendable area, or if I didn't want it serialized in the iAnnotatable, the iAnnotations.
Yeah. Yeah, and it's interesting if I would generate using your generator, a shadow class of POCOs that has all the normal properties plus its subclasses from all of them, instead of, you go all the way down to base, and then base actually extends expando object. The cool thing about it that if you cast it into a dynamic, you can go just A.B.C even on incorrect data. But actually, is
that a feature though? No.
I don't know if that's a feature. So maybe we shouldn't do that. So don't cast it to a dynamic. But I think the interesting thing is that, well, at least if you do it dynamically, if you go to a property that actually exists as a property, it will read the property. And if it doesn't exist as a property, it reads from an internal dictionary. That's the way they implemented, I think, that expando object, or at least you can derive from it and make something. Is that a feature? I don't know. That's why I piloted it a little bit. I was like,
the biggest use case I had from that was the reason why I did it is because I wanted to partially deserialize something and run Firepath on it.
Exactly.
Yeah. So that was my one goal, is that I want to access like ID, version, and last updated. So on a server, you don't need many properties.
Exactly.
But you want to run a lot of Firepath.
So what my colleagues do is they use iSource node for it, because that's the closest you can get to currently. And we do that in the car file compiler because we didn't want to make that completely dependent on R3, R4, R5, R6, or for some of that stuff, we're just reading iSource nodes. And if we progress on the whole iDictionary stuff, you could use iDictionary for it and navigate the dictionary for just for this as well, right? But if you have to read the whole POCO, you still need to parse the whole POCO. But if we say, well, of course, everyone who wants to use POCOs, fine, but we write another parser that parses the JSON into a dictionary, you don't have to put it all into POCOs, and you can read crappy stuff and old stuff and CDA stuff. And
so what would happen, so actually just a question for Gino, what would happen if you use just the straight domain resource deserialize?
It works. I have the custom converters. That's actually what I do. I think I actually just use resource. And I have everything registered. So you just say this is a resource, and it figures out and gives you the correct type back.
But it looks at the runtime type, I figure, or not?
Yeah, well, that's why if you say I want to deserialize into a resource, it goes and it'll create the correct child of resource to say that it's, this is actually a patient. Here's your patient.
Exactly. Yeah. So you're doing get type on it, finding out the real type, and then switching to the deserializer for that type, or.
And then that's actually deserializing the whole thing. I was sort of trying to imply, could I just say,
just a resource field,
resource layer? I don't want all the rest of the properties. I don't want to serialize all that. I don't care about that.
And that's what I was thinking about. It's somewhat trivial, like, for the case of deserializing. You could say, here's an element to stop at. And you could just say, I'm going to go until this point, and then once I hit this point, I'm going to stop. And as far as I know, that would work. Out of the box, because it wouldn't create any object.
It's just that in JSON, the element that you want to stop at is be at the bottom because it's serialized in the wrong order.
Yes. So more likely you would want to say something like, here is a hash set of elements I want.
Yep.
And once you have all of these,
you have all those, stop parsing. Yeah, that would be a wonderful idea.
Of course, the problem comes back to how do you reserialize that? Because the deserializing is easy, the parsing. But if you say, oh, I wanted to change the ID and just reserialize it, that's pretty painful. Doable,
yeah, but I think in Brendan's case, many of these cases we just want to extract some basic metadata, so we have that ready in our index. And I'm figuring Brendan has exactly the same use case.
Oh, yeah, that's trivial.
Yeah, that is trivial.
Yep.
Indeed, there are use cases where you don't. We have use cases where we actually want to update a few of the tags in meta.
Yep.
And then you need to update, and then this wouldn't work because you don't have the rest of the fields to write out again.
Yes and no. You could actually write, instead of just a serializer or parser, if you wanted to write an element updater, you could stream parse and serialize and swap out the one value or the set of values. So you could say, if I'm just trying to change these 3 values, I can stream, and then when I hit those particular elements, swap out, use the value you passed me, and keep going. So you could put that in one operation.
And that could be a very efficient patch.
Yeah, but that makes me think of the way we implemented the masking node currently, which is now layered on top of iTyped element, and you present another view on typed element before you serialize it. It's
but you're not doing, you do the whole thing in one pass.
Yeah,
that's the difference.
That's what I was going to say, because I can see that this stack of stuff that we built, like source node, iTyped element, masking node, blah blah blah, it does take a lot of. I think. Well, no, that's a problem. I think most of them are not Gen 1 objects for the garbage collector. I think they're around for a little bit longer, and so maybe doing this at once and then having all of that released will save will make sure that not a lot of objects go to Gen 2 or whatever in the GC.
Yeah, that's the other reason why I really like the benchmark.net, is because it tracks all of that for you.
Yep. Yeah.
So seeing the amount of difference, and that's why if you're saying, oh, I just want to swap these values, you can literally just read the property type and then use that to write, check to see if you're in the right path, and then write it back without ever parsing it. And then you only actually parse and actually, I don't even know if you would need to parse the field you want. If you're substituting a value, you just overwrite that value, and so you never even parse. You're essentially doing a streaming copy of the text, except that you're checking when you hit that particular element and replacing out and serializing just that element.
It sounds like we're writing another kind of in-memory JSON parsing, JSON patching here.
Yeah. But it's 95% done, because it's the same one that I have there in order to find if the resource type is out of order. I already have all that code done.
Would that be an extension point on the serializer extension method?
I would say it would probably just be a separate, because the whole point of it is saying I'm starting from a string or something like that.
Yeah, that's right.
And I want to do it. So it would just be another function to say, take this arbitrary JSON, and here are the elements I want to overwrite, and give me back my JSON again. Is that what is that the use case?
Maybe. I'm wondering, I'm still thinking in dictionary terms here, but that's because I've been thinking about this for the last week. Is if I make a function, if I make a serializer that works on iDictionary, and you could feed it an iDictionary with the elements you'd like to be patched, you could do the same thing, right?
Exactly, and that's why you can say, you can do it at each of those levels. It's the same thing, whether you're doing it during a normal serialization from the created objects, or to short circuit it for very high performance, you say, well, I'm reading it from the database as a string, and I just have this string. So now I want to I don't actually ever want the POCOs. I don't want it parsed. I just need to change these elements. So then you can do the stream offset like
yeah,
that.
That's, yeah.
And really,
That
you
would just
want
be that would be a very specialized JSON function, right? You're not even deserializing it almost. Yeah.
Yeah, that's just for essentially the thing of saying, yeah, I need to put or insert an element. I think would be probably even more common if you wanted to add, you know, some sort of flag for an E tag or something like that, and you're saying I want this embedded in the resource. Then you would be able to do that very efficiently because you're saying do that, and especially if you expose the stream interface, then you can give that directly to the HTTP send function. So
well, I was going to say this is hardly fire specific anymore. If we find someone who wrote a very efficient patch function on top of system text JSON, we would be done, right?
Yeah, the trick would be integrating it in with all the fire stuff.
Right.
Because
there's probably metadata involved there, fire metadata involved there to get to the right to get the right patching.
Well, you need the proper serialization, because if I give you, that's why you need to be able to serialize properly whatever elements you're trying to insert or replace.
Yeah.
Because if it's primitive and has extensions, or if it's a date time or any of those things, you need to make sure it's using the fire serializer and parser.
You've talked me into putting it into the Microsoft Code Gen now. Excellent. I found your benchmark serialization benchmarks.cs. That's the right file, is it?
Yeah, that's pretty fun. It gives you very nice output. It's kind of a fun NuGet package because that's the most I've ever seen a NuGet package do, that benchmark.net, in that it takes your project, recompiles a bunch of other executables, calls them, and then does all this benchmarking for you in one output, collects everything back, and then gives you the nice reports. And so it's kind of fun because it's like, oh, yeah, it's recompiling and doing all the warm-up runs and making sure it runs everything the appropriate number of times and doing all of the statistical analysis and everything else in a little shell externally. I'm like, oh, that's fun.
Nice.
So the only problem we need to solve then is to have consistent error messages. Well, no, I think we have to make sure that the only thing, well, that's not true either. I was going to say we're trying to really find the minimal set of things you need to report, because I'd love to have the a layer on top of that with the validator that does the validation for once you're away from XML or JSON specific errors. So I think all that code should fix on the very format specific errors, and not anything that has to do with content, because that can be caught on the later steps of the new validator. You could have a very skinny set of validation rules. But that would actually, I think, but if you're reading to POCO, you can't really do that. But I would love to see the parser that just accepts. So let's say observation.value, but it would do it for any type, because I already think that is a semantic check that shouldn't be done by the parser, right? Knowing which types are acceptable for object.value. I know that if you're putting them into POCOs, there's no way to avoid that because you can't put them into POCOs. But it is really one step too much, I think, into validation.
Oh, so you're saying if there was an observation.value that had a patient in it or something like that.
Something bizarre or identifier.
Yeah. Yeah, right now the parser, the one I wrote would never read, value patient.
Right.
Because it wouldn't.
So that is why I was thinking about thinking if I could generate a set of classes that are actually partly dictionary for stuff that is wrong, and partly properties for stuff that is right, we could read the wrong stuff too. and then have the validator catch these kind of errors. That would obviously not be to say that people want their POCOs, because the current POCOs, they are end user friendly, but these POCOs would be very friendly to processing engines like the servers that want to accept basically everything and then start reporting useful data about it.
And it's not a data type issue, it's a property issue, because an identifier looks totally different to a data element definition. And so you're going to end up, it would report from the parser's perspective, what's the system value doing here?
Well, that's where I like the thing I was saying before about the decimal out of range too.
Yeah.
Because you could say something like, I'm reading this, I don't know what this is, here is the raw representation of it in an extension.
But I want that not only for primitives. I want us to have these alternative roads also if this is about having.
Yeah, that's actually
you could discover that. But you're going to discover and say, well, when I was serializing, this wasn't a string. It was an identifier, because you'd then have to derive. I found an identifier, I found a system, a value, and an assigner. Maybe that was an identifier, and imply that that was the type.
Are you talking about on parsing or serializing or both?
Parsing.
Yeah, so for parsing, I think because, the JSON property value, we know whether it's a correct one or not. We already know.
Right.
Yeah.
So we can say if it's an incorrect one, we can stick it into, for instance, its individual dictionary that has its path or something like that, and say, here are things that we found, and I have no idea what they are.
Right.
And here is the path, and here is the value. Huh?
That could be a tree of properties.
Yeah, it could be a tree, or it can be a flat list. However, that's a 6 of one, half dozen of the other. But if you put all those there and just said, yeah, here's the JSON or XML representation.
Yeah,
I don't know what it is.
See, and I think if we can do that, Gino, and then generate an iDictionary interface that returns the normal data for the stuff that came in correctly, but also returns the incorrect data, then a validator based on iDictionary rather than what we have now would just say, hey, that's a crappy value, or you put value identifier here, but identifier isn't expected according to the profile, right?
But it wouldn't know it was an identifier.
I'm sorry?
You wouldn't.
It wouldn't know it's an identifier.
Well,
it's just a blob of values, a tree of values.
It has the last part on the element.
If it's a choice type, it would. If it was value patient or value identifier.
If it's a contained, contained resource, but most of those have resource types. If it doesn't have a resource type either, it's truly crappy. I wonder whether we, at some point you have to say, oh, just like what there are these cases when I wrote the parsers, and you have to handle them too. If you have contained, and there are two resources in a single contained node, what do you do? So in XML, you can easily have two contained children within, two contained resources within one contained node. Are you going to warn the user about that, or?
Yeah. And what's interesting is if you keep track of it in a nice way, you can actually put an option in your serializer to say include garbage or not.
Well, and that is what basically the current stack does that.
Yeah. That's why I'm just thinking that if you kept track of them separately like that, then you could say serialize, and do you want to serialize just what's right, or do you want to serialize everything? And then you could have the option of passing through, knowing the errors, or you have the option of saying, well, I had a bunch of garbage, but here are the actual resources that I had, so that I'm not propagating bad data to my clients, which results in support calls to me.
Yes, exactly. So I made that work currently on all the iSource and iType node stuff, but it's costly. And so we would have to find something that's more efficient than stacks of layers with annotations. That is the current system. Because iSource node, now they can represent any tree, so I got that fixed. But it does have annotations on it. Each node can have annotations, so I have an annotation saying this was originally in the XML file. So I have that. I have that currently in iSource node. And I wonder if we could do the same thing in the generated POCOs, so you can read crap into POCOs as well.
Yeah, I think we could.
The include garbage flag.
Include garbage.
I mean, that's
yeah.
that's what it is. You know, it's whatever.
The reason is that I think the servers, and Brandon probably too, or our server at least, we don't use the POCOs because we want to be able to read any kind of data. Also non-existing resources, which is another case here. That would be just a dictionary. But actually, if we have POCOs that accepted more than that, then what I started out with an hour ago, and I said, if I could just use really the generated classes, but for the metadata, I still need the metadata. I wouldn't need structure definition if I just could read the attributes on the POCOs. So if I'd had a whole set of more flexible POCOs that could also read crap, I could use those POCOs maybe in my server as well, because then they are flexible enough to use in server code. Right now, the POCOs are too limited.
And system text JSON, I think, has something like that, and I think Newtonsoft does too, even. Like if you say, fill out this model, but I want to know the things that it couldn't be filled out, I think they already have a structure for that.
Yeah, I think Newtonsoft does that. I don't know about system text JSON, but
I'm pretty sure it does.
What was this for, the extensions in system text JSON?
I'm sorry?
What was the question, sorry?
Oh, that if you say, here's JSON and here's a model,
Right.
and fill out the model, but
right.
give me everything else in a dictionary.
Yeah, yeah.
I'm going to have to run for my power supply for a sec.
Oh, no worries.
Looking at that project, the CodeGen, the CLI, which one's the performance test?
Performance test is in so that is a separate project in test.
Ah, there it is. Yep.
So there's those the C# basic and TypeScript ones are automated test things that can be run just to see if the code compiles.
Yep.
They don't actually run any tests. They're just like, are these all valid objects?
Yep.
The perf test CS is where I've been playing with the benchmark.net. And then the JSON round trip is my hacky thing of saying, read one of the, for instance, Fire 4.0.1 examples, run it through the parse and serialization round trip, and then compare the characters to see if we ended up with appropriate things.
Yeah.
And so it's kind of annoying because that's actually where I discovered the issue with the clearing the white space. Is that I'm like, hey, this description has a /r/n on the end in mine, and it doesn't in the Firely version, and it should.
And your narrative?
Yes, and that's why. The biggest difference, and I think, Brian, you said the same thing, is it's escaping a lot more Unicode stuff. I have it doing the unsafe, minimal escaping, and it still escapes some Unicode because security. And so I haven't decided, you could churn that off completely by using the regex like I do in there to find those and replace them. But that would mean double traversing every string and things like that. And I don't know if I want to double traverse every string to make the output less secure.
Yeah. Maybe not.
Yeah, I tried to get it through in FireEye. I brought that up and I said, our guidance isn't clear because it says that, where is that? That's in hl7.org Fire data types. So if you look at, for instance, string, it says strings should, and then lowercase not, contain Unicode character points below 32 except for those. And then that's where the trailing white space note is too. But I'm like, okay, but should we put a note here that means I can escape them? Like, what am I supposed to do? Am I supposed to drop them? Am I supposed to escape them? Like, what's proper behavior? And unfortunately, a lot of the thing was, well, this is normative, so we can't add conformance language. And so that would be a breaking change. And so it's, I think I did manage to get through may. So it's saying servers may remove them or may escape them or may pass them through. So that way, at least we're all conformant in saying we're escaping them specifically.
Yeah.
But I'm like, well, we should be escaping them. But whatever.
It would have been nice to actually recommend one.
Well, and that's the problem is right now there's nothing discussing it at all.
Yeah.
And so then I'm like, well, my first thing I tried for was should escape them, because it's should, it's not a shall. I mean, that's not breaking. And there, some of the implementers that were there were like, well, that's not what we do, so I don't want that to be a should. And since there was nothing there, it's like, well, yeah, we can't push that through. So they almost got through should pass them through. And I pushed, there were a couple of us that pushed back pretty hard to say, no, 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 no. There's no way we're going to recommend that you pass through, you know, unescaped control characters in your strings. They're like, well, leave it for someone else to deal with downstream. I'm like, yeah, and break their system. That's the point. But what can you do?
And I assume I should just be running this in terminal, not running it in the debugger.
For what?
Test.
The benchmark.
Well, the performance test? Yeah, you actually have to run it in release. Well, you don't have to. If you try and run it in debug.
About that one.
Yep. Yeah, Control F5 is your friend for that. Yeah. Yeah, overall, I was pretty stoked. Actually, John Stairs is the one who pointed me at benchmark.net for Brendan. But it works really well. It outputs, you know, you can tell it, there's a lot of configuration that you can tell it to keep track of or not. And it generates nice markdown files for you if you want and everything else. So, yeah.
Is it complaining about something?
Good. It's going to be a great new SDK come out soon. I can somehow all of these things are going to merge, right? Doesn't make it awesome.
They will. That's actually one of my struggles right now is I'm also doing a lot with TypeScript. And it's the same thing. It's like I have this much time because this is only, you know, the code gen stuff is this much of my job. And it's like, oh man, I have so many things that I want to do on all these fronts. So that's where I cheat and find the overlaps, like doing profile stuff with code gen so that I can record my videos because outreach is part of my role. So it's like, well, if I can do the education and outreach at the same time that I'm building up the stuff for profile validation, then I get to count the work twice. So.
Yep. Cool. Well, I'll have to play with that, and yeah, I'll get my stuff into there. I'll put another branch up.
Yeah, sounds fun, and yeah, I'm curious to see, and I have that on my notes here to play with, hopefully sooner rather than later, is to see what's kind of the minimum interface we could do to say, here is a serializer parser set of functions, because then that would be really nice.
Yeah, I did take a stab at it, and I just I'm not convinced that it's actually unless just having a factory on the actual Fire client to go and provide, he's put them in. The other thought I had was actually using the content negotiation and actually get you to use that on the inbound side. So the actual Fire client doesn't do it. You just provide the content negotiator and then puts it in. But anyway, that's just a thought.
Yeah, and I guess factory pattern or interface, either way, because it's the same thing. If you pass it an interface or you pass it a factory, whichever pattern, but it should work the same as long as we have that specified and say, here you go, this is all we want.
On a performance note, when I was testing mine with errors in it versus not having errors in it, and async and non-async. Async was significantly slower, and the actually parsing without errors was super quick. Parsing with errors was actually significantly slower versus just aborting as well, which is obviously even faster again.
Yes.
But it was a really unfair comparison. The Firely SDK was going 17 milliseconds, and my other one was going 500 milliseconds, and then the one with the exception was going a second. And I go, what?
Yeah. Yeah, and that's I was starting to play with, because there is one of the examples that has the resource type out of order. And so I wanted to add that one to the list, and I just kept forgetting to put it in the benchmark code, because there is a little bit of a performance hit, but when I've run that test a bunch of times, and it's actually not as bad a performance hit as I thought, because it's literally just creating a parallel memory stream.
Yeah, rolling buffer.
Yeah, and thankfully that's pretty performant. But
cool. All right, well, I've got to jump off onto another call, so I better roll.
Same. Probably should. It's only been, we're only over by what, double? So,
yeah.
Thank you, Ewout, for hosting such a fantastic session.
Yeah. Well, we better give this a big thumbs up for this session.
Yeah, it was amazing.
The end is where all the good stuff is.
So
exactly.
Maybe for next week, should we come together again, or did we discuss everything we wanted to discuss and we need to try out stuff? Or actually, I think I'd love to see what would be the next step for this, if we have any ideas on concrete tryouts. So Gino, shall we meet next week? Is there?
Sure.
Do you want to join Brian or Brendan?
Yeah.
I mean, yeah. Add me.
Yeah, we might get a painful time slot.
Well,
all different time zones.
Yes,
that's right.
Everyone's different, so maybe there's not something that works for everyone. So anyway,
no. Well, only today, because Brian is crazy enough now to join. What time is it at your place now, Brian?
It's 5 a.m.
Oh yeah.
That's not so bad.
Exactly. I've been up for hours.
Yeah. Started at 1 a.m. I guess, or 2. What is it? Yeah.
Yeah, I have to say Eastern time is my favorite time zone for all of these things, because I'm in US Central, so it's 1 hour behind. So it's like, everything kind of gets started at 9, 10 in the morning, and then done at 5, and it's perfect.
Yep.
So practically then maybe me and Gino, and I know now that we want to align this stuff with Brian's, right? So take that. And Brendan.
Brendan's only 2 hours behind, so, but his calendar is perennially full.
Yeah.
So
if you trust us to do the right thing next week, we could report back to you guys and see how we can proceed.
Sure.
Yeah.
Is that better?
I think that's what would happen anyway. Even if it was on my calendar, it may not even be possible for me to attend.
Right. I guess you don't have to
shoot me the slot, and if I'm crazy enough to get up, I'll be there. Otherwise, I'll hear about it later.
All right.
Sounds great.
Okay. Thank you, guys.
Thank you. Thanks, everyone. Fun stuff.
Bye.
Cheers.
Thank you. Bye.